In problem number 3, we want to determine whether the following functions are linear transformations. We know the first thing we want to do is make sure that the function maps the 0 vector into a 0 vector. If that isn't the case, then we know we do not have a linear transformation. Well, in the first situation, this function, as defined here, maps 0 into 0 times 0, 0, as the first component. The second component is also going to be 0. So yes, everything's fine so far. It does map the 0 vector into the 0 vector. So it could be a linear transformation, but we don't know for sure. If it is a linear transformation, it satisfies two conditions. And those conditions are, if we first transform and then scale, or if we scale first and then transform, we should get the same result. So what we need to show is if we first scale and then transform, we get the same result as if we first transform and then scale. Let's try this part first. We're going to scale first and then transform. What does this mean? It means we take f of a scaled vector, which would have been, if we multiply the vector x by alpha, we would have gotten a vector with components alpha chi 0, alpha chi 1, alpha chi 2. If we use our rule, the resulting vector is going to have components. Well, the first component is going to be the first component of our vector times the second component of our vector. Actually, the second component times the first component is the order it's written here. The result will be alpha squared times chi 1 times chi 0. And the second component is alpha chi 2. If we would have first transformed and then scaled, the result would have been alpha times the vector chi 1, chi 0 with first components and chi 2 with second component, which would have been a vector with components alpha chi 1, chi 0, alpha chi 2. Now if we look at these two, they're not always the same. It's not true that if we scale first and then transform, we will always get the same result as if we transform first and then scale. It is true if alpha is equal to 1 or 0, but if alpha is something else like 2, this component is going to be different than this. And so this is not, our first function is not a linear transformation. Let's try the second. Again, does the 0 vector get mapped into the 0 vector? Well, let's see. 3 times 0 plus 0 is 0. That's 0, that's 0. So yes, it could be a linear transformation, but we still need to check. So again, it would have to satisfy that if we scale first and then transform, we get the same result as if we first transform and then scale. So, what is f of alpha times x? Well, that's f of the vector alpha chi 0, alpha chi 1, alpha chi 2, just like before. But now the function says what we need to do is to take 3 times the first component, so that's 3 alpha chi 0, and add to it alpha chi 1. And then this is going to be alpha chi 0 as the second component and alpha chi 2 as the third component. What happens if we first transform and then scale? It's going to be alpha times the quantity. First component is going to be 3 chi 0 plus chi1. Chi0 will be the second component, and chi2 will be the last component. If we perform the scalar multiplication, we get the vector with first component alpha times the quantity 3 chi0 plus chi1, which is 3 alpha chi0 plus alpha chi1. The second component will be alpha chi0, and the last component will be alpha chi2. Well, if we stare at the result of first scaling and then transforming, and the result of first transforming and then scaling, we notice that they really are exactly the same. And so the first condition holds. What do we need to do next? We also need to show that for all x and y, if first we add the two vectors and then we transform them, we get the same result as if we would have first transformed the two vectors and then added them. So let's check and see if that's the case. So here, what is f of x plus y? That would be f of the vector x plus y. We usually write component-wise as chi sub 0 plus psi sub 0, chi sub 1 plus psi sub 1, chi sub 2 plus psi sub 2. If we use our rule for transforming, we're supposed to take 3 times the first component and add to it the second component. So that will be, the result will be a vector with first component 3 times the first component. So that's going to be 3 chi sub 0 plus 3 psi sub 0 plus the second component, which is chi sub 1 plus psi sub 1. And then the next component is the first component of the input, which is chi sub 0 plus psi sub 0. And the last component is the last component of the input, which is chi sub 2 plus psi sub 2. Now, what would have happened if first we would have transformed and then added? We would have found f of x plus f of y would have been the vector 3 chi sub 0 plus chi sub 1 as the first component of the first vector. Chi sub 0 is the second component, chi sub 2 is the last. And then when we evaluate this function at y, it would have been 3 psi sub 0 plus psi sub 1, psi sub 0, psi sub 2 as the vector. Then if we add the two vectors component-wise, the first component is going to be 3 chi sub 0 plus chi sub 1 plus 3 psi sub 0 plus psi sub 1. But notice I could reshuffle these, and I could have written it as 3 chi sub 0 plus 3 psi sub 0 plus chi sub 1 plus psi sub 1. And then the second component would be chi sub 0 plus psi sub 0. And the last component would have been chi sub 2 plus psi sub 2. And of course, the reason I reshuffled the first component terms is because now if I look at it, it is exactly the same resulting vector as I got when I first added and then transformed. And so it satisfies the second condition. So our second function actually is a linear transformation. Now let's look at the last one. If it's a linear transformation, the 0 vector has to map into the 0 vector. So let's check. 3 times 0 plus 0 plus 1, oops, that's 1, not 0. So automatically now I know the 0 vector does not map into the 0 vector, so it is not a linear transformation.